Hi, this is Coach Saiful and welcome to training video number 3. Now so far what we've done is we've covered the must know keywords number 1, the A over B, as well as the must know keywords number 2, which is the A over B more or less than. Now let's do a quick recap before we go on to must know keyword number 3, which is X more or less than A over B. What's that? That sounds rather complicated because it kind of is, okay? So I'm just going to go through the first part, which is the A over B and the A over B more or less than first, very roughly. So if you remember, we talked about how there are two entities, the boys and the girls, the boys being the A and the girls being B, right? And this fraction is known as A over B. It can be a proper fraction, it can be an improper fraction, and if you're given a decimal or if you're given a mixed number, if you're given a percentage, all you have to do is convert it into a fraction that looks like in the form of A over B. Okay, so far you got it, right? So what we talked about the last time in the last video was that the first entity, which is the A, refers to the A over here, right, the numerator, and the second entity, which is the B entity, belongs to the denominator over here, which is the B in the fraction. So in this case, boys is 2 units and the girls are 3 units, right? Very simple. Now we moved on to A over B more or less than, right? And the difference is there is the word more than or less than. Now, if you remember, I talked about entity A, right, and entity B. The entity B will always be the same. So if there's 6 units at the bottom here, entity B will always be 6 units. However, the difference lies in the first one, which was the A, right? So in this case, ribbon A is 1 over 6 more than. So if it says more than, it becomes 1 unit more than 6. 1 unit more than 6 is 1 plus 6, which is 7 units. If it had said less, if it had said ribbon A is 1 over 6 less than, then what would it be? It would be 1 unit less than 6. 1 unit less than 6 would be 6 minus 1, which is 5 units. So in this case, since it's more than, it will be 1 unit more than 6, which is 1 plus 6, giving you the answer of 7 units. And B, like I said, will always be the same. Got it? So we've done the first part and the second part. Now we're going to go into the third part, which is called the X more or less than A over B. This is going to be a bit complicated, okay? But just to give you a rough idea, it's not so different from the first or the second one. Okay, look at how the first child, in this case the first entity, right, and the second child is the second entity. The only difference is there's $200 more than. However, if you read it just one go and you don't know about the language of problem sums, you're gonna get very confused, trust me. The first child gets $200 more than 3 times as much as the second child. What? Okay, so we're gonna go through that today, but before we do that, I just want to remind you, right, where we are in the straight A's roadmap. So we are here, right, on the language of problem sums. As I mentioned before, in order for your child to score straight A's in math, score A's in math actually, all you have to do is go through this simple 3-step system where you prep, drill, and score to help your child score A's in the exams. Now, this is, however, just one part of the bigger roadmap. And in our programs, in our classes, what we do is we actually help your child to go through all these 3 steps, all these 9 phases, yeah? So that's what we're going to do today, the language of problem sums. This is where we are. Let's carry on to the X more or less than A over B. Right, so we have reached this level, right? X more or less than A over B. So let's look at that one just again, right? It says the first child gets $200 more than 3 times as much as the second child. So remember, this is entity A, right? And this is entity B. Now, where do we see the X more or less than A over B? Is where it says X being the $200, right? More than 3 times. 3 times, by the way, is also an A over B, right? So how is 3 turned into A over B? There you go. As a fraction, 3 wholes is 3 over 1. So the A is 3, the B is 1. Now, let me ask you a question. What if I just simply do not look at this part? Okay, so the one that I'm highlighting, $200 more than, what if the question did not have that? It just says the first child gets 3 times as much as the second child. You're like, wait, I know that. That's so simple, right? That's the A over B. So if I had said that the first child gets 3 times as much as the second child, you would know immediately the first child gets 3 units and the second child gets 1 unit, right? So simple. Now, however, what if we reopen, right? We reopen. Well, we re-look at that and we say the first child gets $200 more than 3 times. Now, it means that the first child gets 3 units, as similarly like in the first scenario we talked about just now. But on top of that, there will be $200 more. So why is $200 more than 3 units? It is 3 units plus 200. Now, how this would look like in the model is basically you have 3 boxes plus a certain amount called $200, and the second child would have 1 unit. Okay, so I've given you some more examples over here, so for you to try out. So for example, the third child gets $70 more than 4 times as much as the second child. Let's do this one more time. So what if I block out this part, right? So it says the third child gets 4 times as much as the second child. So the third child gets 4 units, right? The second child gets 1 unit, because 4 is 4 over 1. Now, what happens next? We re-look at the $70 more than, so become the third child gets $70 more than 4 units, right? So, which means that 4 units plus $70. Very simple. Now, what if it's minus, right? In this case, Tony's savings in the first month was $23, less than 4 times as much as savings second month. So, what's the fraction? 4 times, which is 4 over 1. What is the first month? The first month is 4 units, but don't forget it's $23 less than 4 units, which is 4 units minus 23. And the second month, how many do we have? It's 4, right? 4 over 1, so therefore only 1 unit. Done. Very simple. So now I'm going to show you how this is being applied in a problem sum. Alright, so let's take a look at this one over here. It says Mr. Lee has $1,500 to give to his 3 sons. The first son gets $250 more than 2 times as much as the second son. The third son gets $130 less than 3 times as much as the second son. And how much does the second son get? Now, the reason why I'm giggling a bit here is because it gets super confusing if we don't know the language of problem sums, right? So let's break this down bit by bit. Okay, let's go. So it says here, Mr. Lee has $1,500 to give to his 3 sons. Which means what? Which means that the 3 sons get a total of $1,500. We know that much, right? Okay. Now we go down. Mr. Lee, the first son, gets $250 more than 2 times as much as the second son. So recall, right? So the first son, right? What's the fraction? 2 over 1. So the first son gets 2 units and 250 more, so plus 250. And the second son just gets 2 over 1, therefore he gets 1 unit. So the first model is we have something that looks like this. Get it? In the second model, right, let's take a look. It says the third son gets $130 less than 3 times as much as the second son. So let's go back to our method. 3 times means 3 over 1. So the third son gets 3 units, but $130 less. Now this might be a bit confusing because look at the model. It's 1, 2. Why is that 1 unit? No, actually it's 1, 2, 3 units minus $130, right? And the second son, what does he get? Remember, the fraction is 3 over 1, so he gets only 1 unit. Now the next step is of course to combine both of these models, okay, so that it looks like this. The first son, second son, and third son. Now this has a bit of what we call the repeated identity concept. In this case, which identity gets repeated? The second son. Therefore, we put the second son in the middle to compare among the 3 people. You get it? So once you get this, right, it's very simple. You can see $1,500 is the total. You can see all of this as a whole. So in our program, we actually have a simple concept, a simple way to remember things, which is we take out the extra and put in the shortage. So in this case, can you see the extra over here? There's extra 250. So what do we do with it? We take out the extra. So we minus 250. And then we are left with only 2 units. In this case, we also have, what is that? We have a shortage. So we have to put in the shortage. Putting in means that we add $130. Now what that does is we will make this into 1 full unit. Okay? So as you can see, what we do is we minus off, we actually plus the 130 to make it 1 full unit, right? And then, as you can see over here, we minus off the 250 to get rid of this extra. So take out the extra, put in the shortage. Now, as a result, you get $1,380, and that means 1, 2, 3, 4, 5, 6 whole units. So 6 units is 1380, 1 unit is 1380 divided by 6, which is $230. Now, once you get 1 unit, you ask yourself, how much does the second son get? Wait a minute, the second son gets only 1 unit. Therefore, the answer is the second son gets $230, right? Very simple. So the second son gets $230. And that was the end of the X more or less than A over B. And I just want to remind you that that's just one part of the whole equation, the whole roadmap over here, right? So I've actually mentioned a bit about the must-know problem-solving method just now, which is take out the extra, put in the shortage. These are simple things that we can mention to the child remembers, and they can easily solve the problem sum on his or her own. Now, as we also go through all of these things in our program, and I just wanted to invite you to actually give us a try. It's completely free for 2 hours where your child will sit in one of our classes right now, actually experience the holistic math mastery approach live. They will also receive an assessment from our Math Prodigies coach, and you will also receive an individualized study plan based on the test that we actually give at the end of the class. So if you're interested, we give out about 10 to 14 seats every single week. So go ahead and sign up right now if you haven't already done so. And with that, I'll see you in the next video. Take care.
We all use math every day. Math is more than just formulas and equations. It's everything.